So Dave Weiss from Deep Inside the Rabbit Hole has invented a compass for the flat Earth. So I'm going to take a look at Dave's video, Understanding Directions on Earth. And this is where he rewrites the rules of what east and west are. Of course, all of this is in regards of the flat Earth sun and moon clock application, and Dave was one of the investors in this. Now I've taken a look at this application and they've actually added on quite a few features that are pretty nice. You can look up in the upper right here, they have local weather, you can get the sunrise and the sunset, and all of this is accurate information. But there is one glaring problem, and that is right in the middle. That is the sun clock. So let's listen to Dave.
This video is to address the accuracy of the Flat Earth Sun, Moon, and Zodiac Clock app. Many Flat Earth haters say that it puts the sun and the moon in the wrong position. So we'll start out showing that this map is set up for mountain time. It's 12 noon along this line of longitude.
Now to help explain things, I'm going to use my graphic, which is just a copy of what Dave has. And the white line down the middle represents the United States Mountain Time Zone. And it's at 12 noon exactly as he has it.
We'll put our magnetic center in and drop a compass down, and it points north. People that don't understand say that's east, that's west, that's north and south. They're right about north and south because north and south are straight lines.
Now, wait a minute. I've used a compass quite a few times in my life. And you're telling me that this over here is not east and this over here is not west?
6 hours earlier, on the equinox, the sun will be right here. At 6 a.m., that would be sunrise. People will look at the compass and say that the sun is northeast on my app, and they think that east is that way.
So the yellow circle is the equator, and here we have the equinox sunrise. Yes, you put a compass down here, and that straight line direction is to the northeast. And this is east, so I really don't know where you're going with this.
If you drop compasses down along the route, you follow the compasses around, and anyone that's traveling that route east wraps around and goes right to where the sun is. East is always a circle around the magnetic center. West is the other direction.
You are right. On the equator, this would be an east route, and this would be a west route. So let's just take a look at the east route. So if I'm going to start my journey here, the first thing I'm going to do is correct my compass for the local magnetic declination. And then it will be pointing to true north. So my heading's going to be due east, or in the direction of the arrow. But of course, if Dave pointed out, as I move along, the compass is going to be realigning to north. So I'm going to be following that path just by following that eastern heading. And it will take me, like he said, all the way up to the sun. Of course, there is also a direct route, which would be a straight line between these 2 points on a flat Earth. But this is going to be a little bit more difficult to navigate because your compass bearing is always going to change. So here it starts off where you would start heading in a northeast direction. In the middle of the course, it is going to be due east. And as I head closer to the sun, the heading then changes to the southeast. And another quick point is, again, we're talking about the equator. Well, this is one of the latitudes. All of these are latitude lines that run east-west. And yes, they are circles and they are parallel to each other. Now on the flat Earth, there is a difference because latitude lines only circle the North Pole. These are longitude lines. They run north and south. Again, there is a difference because on the flat Earth, they do not converge again at the South Pole. These are latitude and longitude lines on a globe. And what it is just a man-made coordinate system, and it's used for navigation. This way you can determine what is your location on Earth. Now in this case, we have a point that is located at 40 degrees north and 30 degrees west. So now Dave is going to explain why those of us that believe in a globe don't understand what east really is.
So anyone along this line of latitude will see the sun rise east, even though the compass says northeast. All straight lines point south.
Well, of course, the obvious question is, why would a sun ray follow a curved path? Why is it just not going to be a straight line to your location? Of course, this only works at the equator. Here I've picked two other longitude lines. You can see the path following those lines. But of course, there's no sun up here. There's no sun up here. Or does Dave think that atmospheric refraction has magical qualities? So it can bend the light so it happens to come in perfectly due east anywhere along this longitude line? And what about on the December solstice sunrise? From the location here, the observed sunrise should still be to the northeast. But of course, according to Dave's theory, anybody at this location here would see sunrise due east. And this even gets more bizarre, because on the December solstice, sunset is actually to the southwest for every location on Earth. And you gotta wonder, what kind of refraction would be required to make a sun path do this? Even water would not have that capability. And again, that refraction just magically aligns to the southeast for everybody along this latitude line. Of course, there's a simpler and more logical explanation that doesn't require unheard of amounts of atmospheric refraction. Yes, this is the globe model. And here's how it works on the equinox sunrise when the Earth's axis, or north and south, is aligned with the terminator line. And it's quite easy to see that east is parallel to the incoming sun rays. This is how it works on the December solstice. Now the North Pole is tilted away from the sun, the South Pole is tilted towards the sun, so now the Earth axis is not in alignment with the terminator line. But again, you can see that for all locations along this terminator line, southwest is now aligned with the incoming sun rays. And of course, on the June solstice, a half year later, the sun is on the other side of the sun, so now the North Pole is facing towards the sun and the South Pole is facing away from the sun. But again, on the terminator line, everybody sees the sunrise to the northeast. So again, I'll say that there are some nice added on features on this application, but even Dave admits that the flat Earth sun clock is a faulty product. And let's be honest, his explanations make really no rational sense at all. Of course, Dave has the product to sell, so for him, the bottom line is more important than the truth.